The first topic that we study in the pure component of AS level mathematics is quadratics, which by definition is a polynomial where the highest degree of any variable is 2. A general form of a quadratic equation is y is equal to ax squared plus bx plus c. Quadratic formula is used to find the roots of a quadratic equation, which gives us the x coordinates of the function where it cuts the horizontal axis. Therefore, so for example, a quadratic function may cut the horizontal axis at 0 point, at 1 point, or at two particular points. The roots exist or may be found at where the y coordinate is 0, right? Because this horizontal axis is nothing but the line y is equal to 0. Therefore, we can rewrite this as ax squared plus bx plus c in order is equal to 0 in order to find the roots. In this video, we will see where the quadratic formula actually comes from. We have also studied factorization as a method to find the roots of a quadratic equation. Now, in order to derive this quadratic formula, we will first learn how to convert this equation into a completed square form, which is written right here, where h and k are the turning point and a determines the type of the function, but that's to be studied later. First, we will divide this entire equation by a in order to isolate x squared from any of its non-one coefficient. So our equation may be rewritten as x squared plus b upon ax plus c upon a is equal to 0. Second, we know this expansion of x plus k whole square is equal to x squared plus 2xk plus k squared. So we may also rewrite it as x plus k whole squared minus k squared is equal to x squared plus 2xk. And by the way, this is true for x minus k whole squared as well. Okay, like this. Now, this means that whenever we have the expression in the form of x squared added to another term, which is the product of 2x with some constant k, we can close that into a completed squared form here and here. Okay, we will use this in a bit. Therefore, to get the desired form, we will multiply and divide our second term by 2 and can now close this equation into a completed squared form like this. X squared plus 2 times b upon 2a times x plus c upon a is equal to 0. Now this is our desired form. So we can simply, wait. So we can now simply close this equation into a completed squared form like this. X plus b upon 2a whole squared minus b upon 2a whole squared. I will just just rewrite it, minus b upon 2a whole squared plus c upon a is equal to 0. This highlighted term is all a constant. Now we will simplify this and take this constant highlighted term to the other side in order to make room for our x to become independent of any other elements b upon 2a and operations, right? So we can just take this to the right hand side so that this becomes x plus b upon 2a whole squared is equal to b squared upon 4a squared minus c upon a. We will now, in order to take LCM, we will multiply and divide this by 4a. And now we will have x plus b upon 2a whole squared is equal to b squared minus 4ac upon 4a squared, which may also be written as a square of 2a. Okay. Now, in order to remove the squared operation from the bracket here, we will introduce the surd or under root on operation on both the sides. okay, which will cancel the square on the left side of the equation and leave with a positive and a negative sign. We can put it on any side. So let's do that on the right hand side instead, because we are trying to isolate the x completely. So I will just put this plus and minus here. This is not going to hurt our method. We also know from our indices rule studied earlier that the surd operation on the ratio of two terms is actually the ratio of the two terms both inside surd operation like this. Therefore, we can rewrite this equation like x plus b upon 2a is equal to plus and minus under root b squared minus 4ac upon this surd is going to cancel this squared here. So we will just write upon 2a. Now, in order to isolate the x, we can move this b upon 2a to the right hand side in order to get x is equal to minus b upon 2a plus minus under root b squared minus 4ac upon 2a. Now, simply this is how we reach to our quadratic formula. Comment under the video if you find the solution easy and also share with your friends. Thank you.